So in this video, we will express a difference of two trig functions as a product. Now, we have cosine twice, but the inputs or the arguments of each cosine is different. So we've got cosine of pi over 2 and cosine of 3 pi over 2. So they are different trig functions in that sense. In other words, the angular velocities are different. So we're going to need to pick out the difference formula for cosine, which is the last one in our list. So the formula or format is cosine alpha minus cosine beta. That equals -2 times sine of alpha plus beta over 2 times sine of alpha minus beta over 2. So that's the formula. Now in this case, alpha is going to be theta over 2, and beta is 3 theta over 2. Okay? So cosine of theta over 2 minus cosine of 3 theta over 2. That's -2 times sine, and I can work this out long form, right in the big messy fraction if I want, or I can do the arithmetic separately, combine the fractions, divide by 2. I'll go ahead and write out long form. That won't hurt. So let's say not 2 theta, sorry, but theta over 2 plus 3 theta over 2. Hopefully I don't run out of room. All over 2, right? I'm adding them together and dividing by 2. And then sine of their difference. So sine of theta over 2 minus 3 theta over 2 all over, at least inside the sine argument, all over 2, right? So it's -2 times sine. If I add these two together, right? Theta plus 3 theta, I get 4 theta over 2. But 4 theta over 2 would just be 2 theta. 2 theta over 2, which will simplify in a moment. And sine, well, when I combine these two guys, I'm going to have theta minus 3 theta. So that'll be minus 2 theta over 2 will just be minus theta. Okay. So we get, well, since sine is an odd function, this minus sign can come out here and cancel with that minus sign. So we'll have 2 sine of theta times sine of theta over 2. So there we go. That is a rearrangement of what we started with. We've written this as a product, not a difference. We didn't, as with the previous example, previous video, we didn't solve for anything. We didn't get a number. We're just exploring what rearrangements can we do with a product to sum or sum to product formula.